We're going to start 1.3 right now. We're going to get into kind of some more meaty parts of the subject. We're going to talk about addition and hopefully subtraction. So section 1.3, if you're 1.3, section 1.3. Keeping track, we're going to do addition, subtraction, but we're going to stick with whole numbers for right now. We're not going to talk about any negative numbers or fractions or anything like that. I just want to focus on the basics, so we have that piece of the puzzle down, so we can move on in just a little bit. Oh, also, I'll pass out the rule right now. Hey, just put your initials right next to your name, okay? For today's day. If you're not, I don't think you're on that yet. Put your name at the bottom. And then see me after class. So addition and subtraction of whole numbers. Addition, subtraction of whole numbers. Let's say you're walking down the road, right? And you just finished your job as a painter. And you know, on this one road, you got these tract houses. You know the tract houses, what I mean? Like I live in a tract home, where you have all the same pretty much type of house on both sides of the street, right? Let's say you were the painter. You painted 5 houses on the right-hand side. You painted 3 houses on the left-hand side. How many houses did you paint altogether? How'd you do that? You do a couple different ways, right? You use your fingers. Just 1, 2, 3, 4, 5. 6, 7, there's 8. You can add them together. 5 plus 3, that's 8. That's how we do our addition. It's just adding those individual parts together. So when we say 3 houses plus 5 houses equals the 8 total houses that you painted, we do say a couple different words for each of these numbers. These 2 things over here, the things you added together are your add-ins, things you're adding. That's what we call them. I've already said this word today, but what's the thing you get? Sum. That's the sum. Not S-O-M-E, like there's some houses over there. It means S-U-M, like that's our sum. What I'm going to make you do is, of course, you got to memorize addition of single digits, which means like if I say 7 plus 9, you give me 16. Hopefully 16, that's right. If I say 3 plus 2, you give me 5. If I say 9 plus 1, you give me 10. Those single digits, that has to be memorized. If you can't memorize it, there's dot method or finger method, whatever you need to do to get that down. You got to memorize addition of single digits because we have options for adding more than just single digits. We're going to talk about that right now. What about for large numbers? Relatively large numbers here. 426 plus 61. So if I come up to you and I go, really quick, what's 426 plus 61? Now, you go,
47.
I don't know, but it's going to take you a while, right? And chances are you're probably doing something in your head that I'm going to show you on the board. Because adding these large numbers isn't exactly the same as adding 5 plus 5 or 5 plus 6. We actually set this up a certain way in our head. Have you ever set up adding large numbers before? How do you do it?
Bigger numbers, usually on top.
Usually. Does it really matter?
Not really.
Not really.
Whatever's easy.
We typically do that. We typically set this up vertically. So in our notes here, we're going to put this down. When we are setting up addition of large numbers, we're going to line up the numbers vertically. So let me give you an option here, okay? I'll give you 3 options. Which one? Left, center, right?
Right.
Why?
They're in their place. place
Number of
value.
positions.
Okay. The 1 and the 6, that's great. What he said, what did he say? Someone here, repeat what he said. Is place value important for us?
Yes.
When we're adding numbers? As a matter of fact, you know what we're doing when we line up by place value? You might not have ever thought about this, but what we're doing when we're lining up by place value is we're actually thinking of these numbers as expanded form and adding each little part. That's how addition works. It's adding each place value, adding each little expanded version of that, and then we're just doing it all at once. We just don't have to write it out. Does that make sense to you? We're just adding each little piece. So we're going to line things up vertically, and then we're going to add place value by place value. So line up vertically, I'll put a little note there, by place value. And then we're going to add each place value. Okay, so this one, not so much. And this one, definitely not so much. But these are lined up by place value. We've got to have 1s over 1s and 10s over 10s. Otherwise, it's not going to make a whole lot of sense. So let's go ahead and do this. We start on the right-hand side. We're going to add those digits. How many 1s am I going to have?
7.
Perfect. How many 10s am I going to have?
8.
Hundreds? Good. There's really no hundreds down there to add. So we have 487. That's our sum. Bless you, by the way. Let's go ahead and do a couple more. I'll do one more with you. I'll give you a couple to do on your own, and then we'll move on to some properties here. So 4,187 plus 694. Of course, the first thing we're going to do is we've got to line these things up because it's really hard to do this math in our head, right? Isn't it? Would you all do that in your head right away? I wouldn't. It would take me some time. I'd have to actually line it up in my head and go through it, right? That's what I would do. So we may as well just do that here. So 4187. And we're going to line up by place value, so our 6 has to go under our 1. Matching up our hundreds, our 10s, and our 1s. And we add accordingly. But wait a second, what's going to happen? What's our 7 plus 4? Is that going to fit in the 1 spot? Can you have like 11 here? What's that called when you have more than what will fit? What do you have to do? Yeah, so don't forget to carry. Because pretty much what we've done by adding these ones together is we've overloaded the 1's place value. We have now 11 1's. So 11 1's, if you think about it, is 1 1 and 1 10. That's how carrying works. We have 1 1, we bring the 10 over there. So we've overloaded that too much, we just carry that over to the next place value. And we continue to add. How many 10's are we going to have here?
18.
Very good. That's 8 10's, and those 18 10's was 8 10's and 100. That's how the carrying is going to keep going and keep carrying over. How many hundreds do we have?
8.
Great, no carrying there. 4,881, we're done. Give 2 a try, and then we'll move on. By the way, I give you a lot to do on your own here. First, at the beginning of the semester, because if you're anything like most people, did you do math all summer long? No. Yeah, probably not. So I want to get the cobwebs out a little bit. I do math all summer long because, hey, I'm kind of a math dork. But chances are you probably haven't. So I want to get the cobwebs off this thing and see if you can add these together. By the way, I will be walking around every time I give you a problem like this. If you need help, you just raise your hand or look at me like, ah, and I'll come around and help you, okay? So first one, I need you to line that up and add that. Second one I've lined up, just make sure you add that appropriately. Notice how it really doesn't matter for addition whether the big numbers at the top and the bottom. It doesn't matter. Where's my sign-in sheet at? Has it got to everybody on this side? You got you guys see? The way it usually works, it goes down this way, it's going to come up this way. So we pass up this way. Yeah, let's get started on this thing. Okay, the first thing we do, let's look at this first example. What do we do first again? By what? Great, okay. So we'll have we'll keep that 9,000 on top. 9,726 and the 849. Put a little addition over there, that way we know we're adding. If we add, how many ones are we going to add? Everybody? Come on, everybody, how many ones are we going to add?
15.
Okay, 15 or?
5.
Perfect. Either way you say that, that's fine with me. How many tens are we going to have?
7.
Great. How many hundreds are we going to have?
5.
And that becomes 1,000. That's great. How many thousands do we have?
10.
How would you say this number for me?
10,575.
Good. Very good. 10,575. Next one. We got, well, it looks like 12 ones to me. I'm going to carry that up there. Our tens, it looks like we're going to have how many tens? 6. And we got to carry that. How many hundreds do we have? Because we have that one that needs to be carried over. We're going to have an extra 1,000. So you can say 12 hundreds if you want, but the one's just going to keep carried over. How about this? What are we going to have? 3. Plus we got to carry that 1. And then we have
8.
And the 1, we didn't do anything with that, but we still have to write it down there. So did you get 183,262? Raise your hand if you did. Great job. Good job. Very good. Do we feel okay with adding these numbers? So single digits, memorize them, have them down, have some way to use your fingers or something. Thank you, sir. The large numbers, we got a method for that, which is kind of nice. Now, I do have to go through some properties with you about addition. They're not hard properties. I just want you to kind of identify between some of the operations we're working with in this class, what works when. For instance, what would happen if I took the number 7 and added 0 to it? How much am I going to get? What would happen if I took any number and added 0 to it? What's going to happen? Get the same number back again. You with me on that? Anything I choose, if I add 0, I get that number back. So, for instance, 7 plus 0, well, that still equals 7. What if I do it backwards? What if I take 0 and add a number to it? Oh, okay, great. This right here is called the addition property of 0. It's also called the additive identity, if you want to think about it that way. So here, right here, the addition property of 0. This next one's kind of cool. Answer me this question. If I add 5 plus 7 or 7 plus 5, does it make a difference?
No.
What do you get in either case?
18.
Oh yeah, that right there, that ability to switch addition, 5 plus 7 or 7 plus 5, do you know what that's called? Has everyone heard that before? Starts with a C.
Commutative property of addition.
Close. You're emphasizing the wrong syllable, but the wrong syllable. But it's close. Yeah, it's the commutative property. Like you commute down the freeway, you can travel, right? You can switch lanes when you travel. Same thing happens with addition. If you can switch those things, it doesn't make a difference. 5 plus 7 and 7 plus 5 doesn't matter. That's called the commutative property. So let me write that out for you. both equal 12. It's called the commutative. Can you say commutative with me? One more time. Good. Commutative. Okay. There's one more. I got 1, 2. Yeah. I have to have you think on. And you think carefully though. Listen to what I'm going to say. If you add 2 plus 3 and then you add 6, is that different than adding 3 plus 6 and then adding 2? What I'm asking is this question. Do you remember that parentheses mean do this first? Do you remember that? It's a grouping, right? It says do this first and then do whatever's out here. Or do this first and then do this part. That's what the parentheses mean. So a little recall. Let me just remember this. Parentheses mean do this first. We will get much more into order of operations later, but that's the first one is parentheses. So here's the question that I posed to you in words just a second ago. If I add 2 plus 3 plus 6, or 2 plus 3 plus 6, and I group them differently, which means, what if I put parentheses here and parentheses here? Do you think I'm going to get the same answer or a different answer? What do you think?
Same.
If I do this part first and then add 6, or do this part first and then add 2, I'm going to end with what, no matter what?
11.
Yeah. This is 5, 5 plus 6 is 11. Or this is 9, 9 plus 2 is 11. Either way, you're going to get 11. This property right here is kind of a cool property of addition. It means I can group things differently, or I can associate numbers differently. It's called the associative property. Associative means grouping. It means you can associate things. Either way, you're going to get 11 here. It's called the associative property. Okay, last thing we do before we're going to get into subtraction. What if I gave you a whole long line of numbers to add? Can you add them besides doing it just 2 by 2? For instance, if I give you like that. Do you have to add them 2 at a time, or is there a way we can add these all at once? What do you think? How? Okay, so if we follow the same rules that we did before for just 2 numbers, just make it bigger, like a longer vertical list, we can add these all at one time. Just make sure your place values are in order, and you know what? It helps to write neatly. That way you don't mess up those numbers, right? Because if it's all jumbled, then you start adding the wrong place value, and then things really blow up in your face. The paper lights on fire and goes, "No, you're messing me up." That doesn't really happen. Only once have I ever seen that happen.
Do tell.
What now? Yeah.
Do tell.
So if we do lines up vertically, as long as we keep our place values intact, we're good to go. Can you do that for me? Let's work on that one. See what we get. That's a whole lot of ones we got. How many ones did you get when you did this problem? 22? 22? Okay, so 22, we have the 2 there. We are going to carry another 2 as our 10s. Very good. Either way you say, that's fine with me. So 22, carry that 2 up there. Now we're working on our tens. How many tens do we have? 14? Okay, so we're going to put a 4 here and a 1 up there. By the way, do you know about grouping tens when you can to add quickly? There's a way to do that. You try to make as many tens as you can, it becomes a lot easier. So for instance, I see a 5 here and a 5 here, that's a 10, plus 4, that would give me 14. Sometimes that works very well for doing math quickly. Just let you know. So we'll do a 4 here, 1 up there. How many hundreds do we have?
6.
And then no more thousands, 6,642. We're done. How many people feel okay about addition right now? Good deal. We're going to move on to subtraction. Real similar to addition. In fact, we're going to learn that addition and subtraction can be defined as one another, which means a lot of the properties, not all of the properties, work for subtraction, and the methods work for subtraction like they did for addition. Well, these last two, that they don't have. Okay, so let's take a look at this. Let's say that you have like 9 green apples, because they're the best. Have you ever had a green apple? Oh, I love this green apple. It's so nice. And you have a friend that comes along, you say, hey, I have an apple, and he's really hungry, so you can have some apples. And he goes, oh, okay. But instead of taking just 1, he takes 4. Greedy guy. I never liked him much anyway. He takes 4 of your apples. So you had 9, he took 4. How many do you have left? You can do the same way you can addition, right? That's what I'm talking about. The same methods of doing addition work for subtraction. Instead of adding on finger by finger, you can subtract finger by finger. 9, take away 4, gives us our 5 apples that we have left. Really, we should be memorizing single-digit subtraction. So if I say 9 minus 3, you can tell me what that is. Or 8 minus 1, or 8 minus 7, you can tell me what that is. We're not dealing with negatives yet, so I don't need you to tell me what is 5 minus 8. We're not there. But for whole numbers, that's what we're talking about. You need to memorize the single-digit subtraction, or at least have a dot method or finger method for doing that. So we had our 9 apples. Hungry guy took away 4. We have 5 apples left. There are, just like in addition, some names for these numbers in subtraction. The first that we had to deal with, the first number here, this 9, it's called the minuend. That's a weird word, but can you say minuend? Minuend. Yeah, it's the thing that you're subtracting from. This one's kind of a fun one to say. The thing you are subtracting, is called the subtrahend. Isn't that fun? Say it, subtrahend. That's right.
So what's the first one called?
Minuend. Subtrahend. Normally, we really don't say those all that often, but they do have names. That's the other thing. This one you should be able to figure out, though. This thing over here, instead of a sum for addition, we have a what for subtraction? What was that? It's a difference. That's exactly right. The difference between two numbers implies you are subtracting. Yeah, perfect. Now, I said that some of the properties for subtraction are the same as addition. What I mean by that is like single digits, you can use your fingers and stuff. The properties like the zero property we looked at, and commutativity and associativity, those might not work. In fact, let's do a couple examples. If you take 7 minus 0, sure, you still get back 7. But if you take 0 minus 7, does that work for us right now? No. In fact, some of you who know about negatives already, that's a negative number. If you don't know about negatives, that doesn't make sense. If I have 0 of something, I take away 7, how can you do that? That doesn't make any sense to us right now. So that's off the table. That doesn't really work. That implies also commutativity might be a little off. If you take 5 minus 7 and 7 minus 5, do you get the same answer? 7 minus 5 gives you 2. 5 minus 7 gives you, I don't know. I don't know yet. If for negatives, it's going to be negative. So those things don't work. Also, associativity doesn't work. It doesn't work that way. You can't associate for subtraction. So the only property we really have for subtraction is this subtraction property of 0, like the addition property. For instance, if I take 34 minus 0, how much is 34 minus 0? Just gives it right back to us. That's the one that's like addition. Also, one more thing. What if you subtract a number from 14 minus 14, a number from itself? What is a number subtracted from itself? How much do you get?
2.
Okay. Yeah, this is the property of 0 for subtraction. Or the subtractive property of 0. Now, just like what we had over here for large numbers and addition, we do have some ways to add, or sorry, to subtract large numbers for subtraction. And it looks real similar to addition. So let's look at subtracting large numbers. We'll talk a little bit, hopefully we'll have time for this. I don't know if we'll have time today, but we'll talk about some geometry. You ever done geometry before?
Yeah.
Some basic ideas in geometry, and then we'll get on to some graphs, and that'll end this section for us. But first, let's talk about subtracting large numbers. For instance, I give you 958, and I subtract off of that 43. All right, you tell me what to do.
Line them up at place value.
Just like addition, exactly right. We're going to line these things up by place value like we did before. So we'll have our 958. Now, here's an interesting thing. Does it matter which number is on top for subtraction?
Yes.
Absolutely it does. Yeah, it's different than addition. Addition was commutative. Remember, you could switch it. Subtraction, you can't. So you cannot change those things around. Otherwise, you come up with a big mess, right? You can't take 958 away from 43.
Or the negative.
It will be, yeah. We're going to figure out how to do that later with addition rules. But for right now, that doesn't make a whole lot of sense to set it up that way. So here we're going to have our 43. First one goes on top, second one goes on the bottom. We are subtracting. Now we're just going to subtract digit by digit, place value by place value, like we did for addition. So how many ones are we going to be left with here?
5.
How many tenths?
1.
Hundreds?
9.
Good. Nothing subtracted from there. We get 915. Are there cases where this doesn't work out exactly the way we want it to? For instance, what about 9437? Great, there's that word, borrow. We do have to borrow. Essentially what we're doing is the opposite of carrying. You're going to overload the place value temporarily. So we look at this problem, we go, okay, I obviously can't take 7 ones away from 4 ones. There's not enough to cover it. So what we do, typically people will just cross out this number and put 1 less. You're taking 110 away from that 9, making it 8. Where that 10 goes is you're overloading the ones place. So instead of 4 ones, well, that 110, that's 10 ones, right? That's 14 now. So we could write a little 1 there, or you can cross it out completely and write 14. And we look at like place value that way, or sorry, this way. 14 minus 7, now we have 14 ones, we've overloaded it. How many are we going to have now?
7.
Are you still with me, guys?
Yeah.
How many tens?
5.
Perfect. Try a couple of these on your own, and we'll call it a day after that. So here's some examples for you. Let's do this one. That one. Oh, you know what a good one for us? We'll do this one down here. So set them up like you know how to do, and then subtract place value by place value. If you have to carry, or sorry, if you have to borrow, then borrow appropriately. Now, I'll be walking around. If you need help with this stuff, you just let me know. take about 30 more seconds on this, and then we're going to go over it as a group just a little bit. Hopefully you set them up vertically. Okay, perfect. So first one, we look at this place value by place value. 3 minus 2, of course, single digit. We have to memorize that. We're going to get a 1, a 2, a 0, and a 9. Did you get 9,021?
Yes.
Awesome. Next one, we're going to have to do a little borrowing. In fact, a lot of borrowing. Here we borrow from the 3, making that 14. 14 minus 6, we're going to get 8 ones out of that thing. But here we don't have enough 10s to cover our 9, so we have to borrow again. We have to make that a 12. 12 minus 9, we get our 3. One more time. You cross it out, move it over here. 11 minus 8, we get. Did you get 338?
Yes.
Awesome. Last one, we can do a couple different options here. You can do a double borrow, or you can cross out the 90. That's possible as well. Some people like to go, oh, well, where do I get a number for the 0? There's none here. You have to go all the way from the 9. You can cross the 9 out, making that an 8, make that a 10, and then cross it out, make it a 9, and do it. Or you can think of it this way. Here's 90. 1 less than that is 89. And I put the 0 there. That works as well. Does that make sense to you? Either way, it doesn't really matter. 10 minus 4, we're going to get 6 ones. We're going to get 7 tens. We're going to get 500s. We get 576. How many people feel real good about addition and subtraction of large numbers? Awesome, guys. I'm going to put some homework up on the board here for you, and then we'll be out of here. Bless you. It goes by really quick. Don't let it intimidate you. It's actually not a whole lot. I give you the sampler, right? Sampler. It's going to be page 12 through 15, 1 through 8, 13 through 17, 29 through 40, 47 through 56, 63 through 68. That is going to be due tomorrow, so I do want it tomorrow because I'm going to give you more homework tomorrow. So the first week, we do have a lot of homework. It's nothing that's going to take you too long, but you are going to have some about every day, okay? Just a piece of paper, make sure your name is on it, and that is about it. Last time we did the whole subtraction and addition thing. Today we're going to talk about perimeter for a little while. I told you we're going to get into a little bit of geometry. Then we'll talk about manipulating some graphs, looking at graphs for just a bit. And after that, we'll be done with our section, and we can start talking about rounding and estimating and using that to round some numbers as well. So, if you're keeping track, we're still on section 1.3. We're going to talk about perimeter, though. How many people have actually heard of perimeter? Raise your hand if you've heard of perimeter. If you watch, I watch a lot of 24, like the series, you know? No, secure the perimeter. I'm just getting into it. I know it's like a long time ago, but it's an awesome show. And like, secure the perimeter. Well, what does it mean if we're talking about the perimeter?
The area around something.
Yeah, pretty much. That's the idea, right? I'm going to steer away from the word area because in math and geometry, area and perimeter are two distinct items. So, but I think that you have the right idea down. The perimeter is really just the distance around some sort of object. If we're talking about the perimeter of this building, what we're talking about is how many steps it would take you to get around the building. Are you all with me on that? Nod your head if you're with me on the whole idea of perimeter. So in our math class, we're going to say that the perimeter for us is the distance around what's called a polygon. Not polywog, right? Not that. Polygon. Have you ever heard of a polygon before? It's basically just shaped like a rectangle or a triangle or a square. It's a closed figure with straight sides. That's really all a polygon is. So let me go ahead and give you a couple definitions here. When we say perimeter, what we mean is the distance around a polygon. And if you've never heard of a polygon before, what we're talking about is a closed shape. Closed means water won't fall out of it. So like this right here, is that a closed shape?
No.
How about that? Yeah, that would be closed. If you can turn around, water won't come out, it's closed. If it has a little open side where water could pour out of it, that would be open. So that's a polygon. I'll give you a little definition of polygon. It's just a closed shape with straight sides. And you've seen lots of polygons. You've seen things like triangles. Those are polygons. This is a weird looking shape, but it's still a polygon. Rectangles. Anything that has straight sides and is closed in, we call a polygon. So if we're talking about perimeter, which has to do with these polygons, could you find me the perimeter of this shape? Let's say we have this would be like a trapezoid. This is 5 inches and 4 inches. Let's make this one 3 inches, and this down here is 8. Of course, this is not to scale. Can someone on my right side of the room, can someone explain to me how you would go about finding the perimeter, or in our case, the distance around this figure? What would you do? Yeah, that's one way to find the perimeter. So perimeter is just you take those sides, you add up the distances, and that gives you the total distance around that figure. Raise your hand if you feel okay with this perimeter concept. Good deal. So in our case, the perimeter, we'll say capital P for perimeter, is someone shout out a number. How much is the perimeter here?
20.
Okay. And we don't just want to say 20, do we? We want to be a little more specific than that. We want to say 20 miles. Is it 20 miles? Is it 20? It's 20 inches. So when they give you units, give units back. That's really the basic idea here. You know, I'm doing a lot of home construction now. I do that on the side, well, specifically with my home at this point. But oftentimes, you want to improve homes by like laying down new carpet. Or sometimes if you lay down new carpet, you pull off what's called the baseboards. You know what baseboards are, right? And you got to get new baseboards. Are you going to go into Home Depot or Lowe's or wherever you get your baseboards and say, yeah, I don't know how much baseboards I need, so just give me like 1,000 feet of baseboards for my room that's like 5 feet by 10 feet. Would that be a good idea?
No.
No. So how do you find out how much baseboards you need? Understand that the baseboards around the room, that's a perimeter concept, isn't it? If you want to put baseboards around this room, wouldn't you want to measure the walls and figure that out? So we use perimeter in instances like that. But typically, we have a rectangular room. Well, that's almost right. Let's just pretend that's rectangular, okay? Does that work for you? Let's say that I measure my room and it's 17 feet by 12 feet. Do I have to measure the other two sides in order to figure out the perimeter for this room, if that thing is a rectangle? Explain that.
If it's on one side, it should be the same on the other. If it's a perfect square.
Sure, if it's a rectangle, yeah, one side's exactly the same as the opposite side. So why don't you go ahead right now, figure out the perimeter of this shape for me, okay? Figure out how much feet of baseboards I'm going to need for this room. True or false? We need only 29 feet of baseboards.
False.
Yeah, that's definitely false, right? That would just take into account half of my room. In order to do this correctly, we know that if this is 17 feet, what was your name?
Jack.
You just write, this is also 17 feet. And this would also be 12 feet. So if we add those together, we just add up all the sides, we're going to get how much there?
58.
So the perimeter for our room is 58.
Feet.
Yeah, 58 feet, exactly right. There's one thing I'm going to need you to do. I'm going to need you to read through page 22 in your book for the words about addition and subtraction. Get used to those. Like for addition, we have sum or plus, added to, combined with. For subtraction, we have difference, less than, is subtracted from, things of that nature. So read through those, get comfortable with those. Most of them you'll know already. Just make sure you do have those down, because eventually we're going to get into word problems and be using those words. You still with me? You awake today? Okay, good. You know, a little while ago, have you ever noticed that there's lots of Starbucks? Is this new information for you? No, there's this one place. Did you go to Fresno at all? There's one place in Fresno where you can stand and almost, I think you can see 4 different Starbucks if you stand right in this one spot. It's in River Park. Do you know where River Park is in Fresno? There's like 2 independent ones. There's one in Target. There's one in Barnes & Noble, and there's one really close. Maybe there's 5 of them. I don't know. But there's a lot of Starbucks around. So they did this research, and they found out how many Starbucks are in each town. And this is old data, so there's probably more than this. And it turns out that Los Angeles had the most Starbucks. No wonder why those people are so high strung, right? Have you ever driven on the 405 before? You would understand it. Okay, I used to live down there, so it's pretty crazy. And then I think they had, I'm going to add up a little bit more of this. They probably have around, let's say 58 at this time. The next place was San Francisco. And of course, this counts like the Starbucks within Target and things like that, those small ones. San Francisco had a little bit less. They had 47. Sacramento had quite a few. I think they had 33. And Fresno was close. Fresno had 25. So the number of Starbucks for these cities. I just need you to get familiar with reading graphs correctly. So could you tell me some of this information? What city had the most number of Starbucks? Of course, that would be how much? 58. And what city would that be?
Los Angeles.
What city someone else had the least number of Starbucks? And how many do they have?
25.
Can you see how many total Starbucks there are in these 4 cities? Well, just tell me, how would you figure that out?
Add all 4.
Add all 4. Could you tell me the number of Starbucks in what's considered Northern California? That would be Fresno and above. Could you do that? What cities would that be?
San Francisco, Sacramento, Fresno.
So if we add these 3, we'll get Northern California. How many people feel okay about reading this graph then? Good, all right. Well, believe it or not, we're done with section 1.3.